How these cytokines mess with your insulin signaling. Now, okay, let's get into the cellular science behind insulin resistance. When insulin binds to your insulin receptor on a muscle cell, it normally activates the pathway that allows glucose to enter your cells. More importantly, your muscle cells, to create energy and movement. Receptors are proteins found on the surface of cells, or actually inside your cells, that receive and respond to specific signals like hormones, neurotransmitters, or other molecules. Think of them like locks, and the signaling molecules like insulin are the keys that fit into them to trigger a response inside the cells. In terms of insulin receptors are specialized receptors on the surface of muscle, fat, and liver cells that bind to the insulin when insulin is released into the bloodstream. So your insulin travels passively through your bloodstream, carried by the flow of blood until it reaches its target tissues. So that would be your muscles, fat, and liver cells. Once your insulin molecules are released from your pancreas, your insulin enters your bloodstream and is transported throughout your body. So insulin then moves from your blood vessels into surrounding tissues, reaching your muscle, fat, and liver cells. And when insulin comes into contact with insulin receptors on these cells, it binds like a key fitting into a lock. This then triggers a series of cellular signals that allow glucose to enter the cells for energy and storage. If your receptors don't work properly due to inflammation or excess body fat, it leads to insulin resistance, making it harder for glucose to enter the cells, and this then increases your risk of type 2 diabetes. But pro-inflammatory cytokines disrupt this process of insulin signaling in 4 ways.